All right, Unit 9, Part 5. I'm calling it Lecture 9, but I mean Unit 9, Part 5. Should be the last one. So let's talk about theorems for a little bit. So I'm going to do this theorem on page 189. Page 189. So this one at the bottom of page 189. Sorry, it's not focusing, but that's what it is. Okay, what are theorems? As I say, you will have to prove a theorem in the exam. It will be a 30-point question or a 25-point question. So you need to know how to do them. Now, there's only one thing that's new about theorems, right? You learn this one thing, and everything else about proving theorems is exactly the same as all the other proofs you've done so far. A theorem is a formula which can be proven with no premises, all right? This is what you have to hear, please, and follow, all right? You will be asked in the exam to prove this theorem, this formula. Please do not put that formula at the top of the proof. Put it at the bottom. If I was in class now, usually I scream this because I want everybody to do it, and if you do this one thing, right, everything else is easy. It reduces to the problem that we've seen so far, right? It's exactly as hard as the ones we've seen so far, so you can do it. If you don't do this one thing, you're completely lost, okay? So you're asked to prove a formula. So your page will say, right, prove this theorem, okay? The big mistake, which if you do, you will lose all of the points, is to write one dot and to write that formula up here as if you are given it as a premise. You are not given it as a premise, okay? You are asked to prove it, right? So the entire game when it comes to theorems is the formula you're asked to prove, the theorem you're asked to prove, put it down the bottom. You draw the line, you draw the vertical line, and you put that formula down the bottom, whatever it is, right? Because it's a task to prove this. A theorem is a formula proven with no premises, right? Which means, since there are no premises, the first step in the proof has to be an assumption. One, in any proof for a theorem, looks at least like this, right? An assumption. The discharging of the assumption will be, discharging of the first assumption will give you the formula itself, right? So the justification is going to be either conditional proof or indirect proof, because they're the only two rules governing the use of assumptions. Sorry, I know it's very dark, but the light will be to this side. The main light puts a big glare on it. All right, we'll do our best. Okay, but anyway, so do the right thing, do the first thing right, put the formula you're asked to prove down the bottom. Everything else is easy, right? Now you've got your conclusion. You know, your conclusion is your theorem, right? The theorem is the conclusion you're asked to prove. Okay, so enter your mantra. What is the structure of your conclusion? What is this thing? If it's a conditional, you'll set up for conditional proof. If it's a negation, you'll set up for indirect proof. Sometimes you might have to manipulate it, right? If you look through the text, she'll tell you how to turn, by the use of conditional exchange, you can turn a disjunction into a conditional, right? Double negate the left disjunct, use conditional exchange, you can do that. For any formula, you can turn it into a negation by taking that formula and double negating it. Then that formula is the negation of, that is the main operator's negation, the negation of whatever the original formula was. So you can turn anything into the form of the negation. So whatever the formula is, whatever the conclusion is, you can turn it into the form which is the conclusion of an indirect proof or a conditional proof. But this formula is a conditional, right? So conditional proof is going to be the one to use here. Okay, it's just a matter now of doing the right thing for conditional proofs, which is seeing what the antecedent is and seeing what the consequent is, putting the antecedent up the top as the assumption and putting the consequent down the bottom as what will mark the end of the subproof. Okay, so this is it's as easy as that, right? This is a big, long, ugly formula. You're supposed to prove it with no premises. That looks hard. Not really. It's just a matter of identifying the major operator, right? It's a matter of first and most importantly, putting the thing down the bottom of the proof. Put the formula down the bottom of the proof. Do not put it up here, right? This is the big mistake that everybody makes, lots of people make every year. They say 1, boom, like what? Are you given that? Is it a premise? No, you're asked to prove it. If you put it up the top, where are you going with your proof? You've already got the formula you're asked to prove, so every move you make is wrong because you're not given this formula as a premise, right? But you're deriving things from it. You can derive things from it. You're not given it. You're asked to prove it. Okay. So don't put the thing at the top. Draw your vertical line, setting up for the proof. Put it down the bottom, and then treat it as a conclusion, which is what it is. Okay. So this is a conditional. I have to identify the major operator. Sorry if you can't see this very well, but this is the hook. That's the major operator. It is if P, then if Q, then R, then if Q, then if P, then R. Okay, so that's the antecedent, that's the consequent. Antecedent goes at the top. P, hook, Q, and R. Assumption for CP. Right? I put my consequent down the bottom. Right? Let me stress that. I put the consequent down the bottom. Right? How do I know when I finish this thing? Right? I put the consequent down the bottom. Right? Just doing that simple thing. Q, hook, P, hook, R. This big, horrible, ugly task, right? Deriving this god-awful formula is easy. Is a lot easier. Now you're given this as if this is a premise, and this as if this is a conclusion. Right? Somehow you have to get from there to here. Right? So right, this is simpler. This is simpler. It's now equivalent to a problem where you're given this as an assumption and this is a conclusion. Sorry, this is a premise and this is a conclusion. This is just, the first step is your assumption. Every theorem, first step, always an assumption. A theorem always, not sometimes, not never, but a theorem always begins with an assumption. Okay? Because what is a theorem? Formula proven with no premises. Okay, if you did that right, you've got the consequent down the bottom. The consequent down the bottom means that's where you look, right? You look to the consequent and you say, what is its formal structure? This is what you're tasked with proving. It's as if you're given this is step 1, right? You've got that assumption. From that you have to derive this. What is this? This is a conditional. I should set up for conditional proof inside this conditional. All right, let me do that. All right, and again, just apply the rule. Whatever the antecedent of the conditional you're trying to prove is the assumption. Whatever the consequent of the conditional you're trying to prove, that marks the end of the subproof. So the conditional here is P hook R. P hook R is what goes here. Okay? So that's step 2. What's the justification for step 2? It is assumption, setting up for conditional proof. Assumption, brackets, C, P. Boom. Okay? All right? And what do? I return to my mantra. I look at my conclusion. What is it? It's a conditional. Okay? So I'm going to set up another conditional proof, right? I'm assuming P. What's the consequent? It's R. Okay? Right? So what are we up to? This is step 3. P, right? Again, assumption for conditional proof. Okay? And now, what is the problem, right? You've got these 3 formulas. If P, then if Q, then R. You've got Q, you've got P, right? And with using those 3 formulas, you have to somehow derive R. And that's it. You have to get R from these things. That looks pretty simple. A couple of modus ponens away, or maybe even one. Right? And then you just anoint the proof. That is, supply all the justifications, which is going to be CP, I don't have the numbers yet, this will be CP, and it'll be CP over here. Right? Some number to some other number, right? This will be 1 to 1 dash whatever. Okay, so I've got P, so therefore I've got Q, hook R. Right now, the structure of my conclusion is just a straight up R, so I'm not looking for another, I'm not looking to set up another, I'm not looking to set up another conditional proof or anything like that. But P with P hook R, so 1, 2, 3, modus ponens 1 and 3, gives me this, MP, sorry, it's ugly and weird, modus ponens 1 and 3, and then I've got Q and Q hook R, so modus ponens gets me to R, right? Another modus ponens, and then, so it's 1, 2, 3, 4, 5, 4, 5, so 6, 7, 8, right? So the justification for this one is what? Conditional proof 3 to 5, CP 3 to 5, justifies my P hook R. CP 2 to 6, conditional proof 2 through 6, justifies if Q, then if P, then R. That's the assumption, that's the antecedent, that's the consequent of Q, P, or R. CP 1 through 7. 1 through 7 is the final justification for P hook Q hook R. If P hook, if Q hook R, then Q hook P hook R. Right, so it all reduces to just putting the thing in the right order. This could be the lecture, because here are my kids. Hey mate. Come say hi to my class. I'm giving a lecture. Hey Freya, how you doing? You want to say hi, August? No?
Daddy's in here.
Yeah. Come. Hey mate. Say hi to the kids. I use your room as a lecture hall. All right. This is August. How you doing, mate? Okay, so that's theorems. So you just make sure you put it down the bottom. Let the structure of your conclusion determine your what move you make, right? Which is what assumption you make. Hey Eden, come say hi to my kids. It's my students. Come. Say hello, students.
Hello, students.
Good play.
And we need to wash our hands. I'm ready.
Yeah, good on you, Freya. All right, so that's how you do it. All right. All right, that'll do for lecture for Unit 9. Now you have to study for the exam, and we'll figure out how to take that. So,
Daddy, can
yes.
I write something? You
can say something. You're going to say, good luck in the exam, kids?
Good luck in the exam, kids.
All right, thanks. All right, and we'll see you here again soon.